Hello, this is 829, Lecture 1, and the title of the lecture is Projectile Motion. In this lecture, we solve an important word problem involving projectile motion. It uses the solution to quadratic equations that we have already studied, namely solving by factoring. The equation we consider is the real equation developed in physics. Let's do an example. A Little League baseball player throws a ball upward. The height h of the ball in feet, t seconds after the ball is released, is given by the quadratic equation h equals minus 16t squared plus 30t plus 4. There are three questions that I ask. What is the initial height of the ball? Part B, how long does it take the ball to reach a height of 18 feet? And how long does it take for the ball to hit the ground? Let's solve Part A. In Part A, we are asked to find the height at which the ball is released. Since t represents the number of seconds after the ball is thrown, t equals 0 at the time of release. So if we let t equal 0, we substitute it into our equation and solve for h. So substituting 0 for t, we have h is equal to minus 16 times 0 squared plus 30 times 0 plus 4. And when you compute this, you get 0 for the first two terms and 4 for the last one. And so the height equals 4. So the answer to part A is the initial height of the ball is 4 feet. For part B, we were asked to find the time it takes for the ball to reach a height of 18 feet. This means you want to find t when h is equal to 18. Again, our equation was h equals minus 16t squared plus 30t plus 4. And now we're going to substitute 18 for h. So 18 is equal to minus 16t squared plus 30t plus 4. But now we're going to move that 18 to the other side because, as we know, to solve for factoring, we always have to have the quadratic equal to 0. So we're going to subtract 18 from both sides. That gives us 0 is equal to minus 16t squared plus 30t minus 14, because 4 minus 18 is minus 14. And now we've written this in standard form. Now, my dear students, you might notice that there's a common factor of minus 2 in there, and it is easier to factor things when the leading coefficient, the coefficient of t squared, is positive. So we're going to divide both sides of this equation actually, by minus 2. So we get, after we divide by minus 2, 0 is equal to 8t squared minus 15t plus 7. And now this is then a factoring problem. So we factor this, and again, you should be able to factor this. We will get 0 is equal to 8t minus 7 times t minus 1. Again, 0 is equal to parentheses 8t minus 7, close parentheses, new parentheses, t minus 1, into parentheses. So we factored that. Now, using the 0 property or 0 factor property, we will set 8t minus 7 equal to 0. And we will solve that and get t is equal to 7/8. Or we will set t minus 1 equal to 0 and get t equal 1. So there are two answers. How can there be two answers? Well, after 7/8 seconds, the ball is 18 feet above the ground on its way up. And after 1 second, the ball is 18 feet above the ground on its way down. So you see, the ball reaches a height of 18 feet after 7/8 seconds and after 1 second. In part C, we must determine the amount of time it takes for the ball to hit the ground. When the ball hits the ground, how far off the ground is it? Well, it's 0 feet off the ground. So what we want to do is find t when h is equal to 0. Again, our equation was h is equal to minus 16t squared plus 30t plus 4. So substituting 0 for h, we have 0 is equal to minus 16t squared plus 30t plus 4. Again, we're dividing all the way through by minus 2. That will give us 0 equal 8t squared minus 15t minus 2. And we have to factor this. So this factors into 0 is equal to parentheses 8t plus 1 into parentheses times new parentheses t minus 2 into parentheses, having factored it. We will now use the 0 property of factors to set each of those factors equal to 0. So if we take 8t plus 1 and set it equal to 0, we will get that t is equal to minus 1 over 8. If we take t minus 2 and set it equal to 0, we will get t is 2. Now since t represents time, t cannot equal minus 1 over 8. We reject that as a solution. The math is good, but the physics is not. Therefore, the answer is t equal 2. The ball will hit the ground after 2 seconds. Here's one for you to try. An object is thrown upward from a building. The height h of the object in feet, t seconds after the object is released, is given by the quadratic equation. H is equal to minus 16t squared plus 36t plus 36. The questions that I ask are, what is the initial height of the object? Part B, how long does it take the object to reach a height of 44 feet? And part C, how long does it take for the object to hit the ground? I'm asking you to pause the video to work the problem and hit resume or play again to check your answer. Good luck. Let's see how you did. The answers are, for part A, the initial height of the object was 36 feet. The answer to the question of how long does it take the object to reach 44 feet is 1/4 second and 2 seconds. And the question of how long does it take for the object to hit the ground is 3 seconds. In closing, remember, time is precious. Each day must count. Do the math. It will make you strong. More later and soon. Till then, take care.